Hello students, if you remember in last part we have just started the oscillation chapter and then we have seen different part of the oscillation chapter, that what exactly we have seen reference circle method that we have seen, and apart from that projection of uniform circular motion on a diameter, it is performed as a simple harmonic motion, that also we have seen. Now today we have to see the phase in SHM. Before going into detail of phase in SHM, I would like to give again one of the example for projection of a particle performing UCM, how it will perform the simple harmonic motion. That I would like to give another better example for this, that already we have seen that topic. Still I would like to tell you the same thing again. Suppose we have created this as a circle. Okay, this is our x-axis, this is our y-axis. Okay, this is x, this is the y-axis. Now what is the problem here, or how we can just represent that motion? Just I will like this y-axis again, it is found to be little bit tilted, so just make it, correct it and write down it as a exactly vertical. So I will write it here like this. So such type of, this is a y-axis. Now see, suppose we have one rod, to that rod we have connected one string, and the string has one stone or spherical something, we can say bob of simple pendulum, just like this. Suppose I have such type of rod, I have just make it horizontal, such type of rod. At the tip of this rod, what we have done, at the tip of this rod we are going to connect here the string. So suppose this is the string we have tied here. At the bottom of this, here is a spherical bob or heavy weight we have connected. Such type of rod we have. Now this portion we are going to put on the circumference. So this would be the tip. In this place, when we put, suppose let us imagine this pen itself as the tip. This pen, this is the tip. Just I have hold it like this. Okay. So when we hold it like this, the string goes downward because of gravity, as we know, because that's heavy weight. Now remember, you have to just note down the point where string touches to this x-axis. You have to note down the point of the string where it touches to x-axis. When we hold it here, it never touch, it goes downward, leave it. So we can say that point comes here somewhere, this one is the point. Okay, after some time, as we are moving upward, suppose I move with this pen or that rod here, okay, its string comes downward like this. This would be the position of the string now. Okay, just forget the stone goes downward like this. Just we want to note down the position of that string which touches to diameter along x-axis. Then when this rod goes here, the string touches to this point. Again rod goes here, string touches to this point. Here it goes, string touches to this point. Okay, so in this fashion, as we can write this point as E, F, G, H. As the body or particle move from H to E, the projection, this string is assumed as a projection of that rod. At this position, the projection comes here. At this position, projection comes here, so on. Okay, so this point, as it is moved from H to E, rod move from H to E, anti-clockwise direction, the projection move from H to O. Did you got it? It will complete 1/4 of the arc of circle. Apart from this, again as this rod moves somewhere here, again the rod goes downward. The pendulum, we can say, this is the projection. It comes here, it goes here. So this would be the projection. It comes here, it goes downward. That means this would be the projection. Are you getting? Apart from this, now in reverse direction you can't do it, because string goes downward. So what we will do, we will rotate this circle. Just rotate the circle and do the same thing. Just rotate the circle, move this E at a place of G, move this G at a place of E, and do the same thing. You will find that in that case, just I have not drawn the circle, but if you draw it, it is little bit the same thing we get. Suppose I have drawn it like this, small circle I will draw. Suppose this is small circle. Suppose it is circle, I know it does not look like a circle. X-axis, this is y-axis. So what we have done, change the position. So this would be the E now, this would be the G now, this is H and this is F suppose. Suppose I have rotated like this. Then this becomes F and this becomes H. In this situation, now these things comes here like this. This part already we have done, na? So this comes here. These points are these points. Now do the same thing. Rod put it here. It goes projection like this, projection like this, like this, like this, and like this. Okay. When we have started here at the point H, when we come again at the point H, one rotation get created. While doing this rotation, what the projection has done? It will start here, goes in this direction, in a semicircle. Then again, half remaining semicircle, it can come back to the same position H. And that is nothing but this motion, to and fro type of motion, is simple harmonic motion, which result into the motion performed by the rod in circular motion, and its projection perform a straight line oscillatory motion, that is said to be simple harmonic motion. This topic I have just told you by taking another example. Let's go further. The next topic of our syllabus is nothing but what? Phase in SHM. What is meant by phase? Basically phase of SHM. So if you remember, we can represent the displacement by one simple formula, x equal to, as we know, you can write here, x equal to a sine of omega t plus phi. Phi is constant of integration, if you remember. Then in this equation, this term omega t plus phi is said to be phase of SHM. This term is said to be phase of SHM. At a time where motion start, initial phase. This is a phase, latter phase, and that is said to be, sometime it is said to be epoch. This phi is said to be epoch, and this is said to be initial time phase, and total thing is said to be phase in simple harmonic motion. Particle perform a simple harmonic motion. What the phase it has? It has the phase of omega t plus phi. Is that clear? Apart from this, in your book what they have done, they try to explain the same thing in terms of special cases. They have mentioned the special cases. What these special cases are? So let us draw again the circle. Let us suppose this is circle. I know that it is not exactly, suppose it is circle. Such type of thing is here. Again take this as a point E, F, G, H. I have changed little bit the names now. E, F, G, H. Let us consider this as the origin O. Okay. So what the special cases he has considered, just we know. We have the circle, we have just divided the circle into 4 equal parts. So this can be assumed as a 0. If you remember, we have seen omega t plus phi, the angle made here at P0. Then here it is omega t, or it is phi, and here it is at point P, it is omega t. The total angle is theta is equal to omega t plus phi. This thing already we have learned in the same topic, projection of SHM. Projection of UCM as a SHM along the diameter. That is a topic that already we have learned this part. Now remember, in this case, suppose we assume here this theta is 0. Theta is 0 here at a point E. At a point F, what is theta? Theta is 90 degrees. Here it is 0 degrees. At G, theta is 180 degrees, because this angle we have to consider 180 degrees. At the point H, what is theta? Theta equal to 270 degrees. Okay. Again at a point E, what is theta? Theta come to be 360 degrees. I hope you know these things. The whole angle can be divided into 4 parts. Basic 4 parts, 90, 180, 270, 360. Suppose the motion start from point E. Motion start from point E, then this GE is said to be mean position. This is said to be mean position. This is what? Extreme up. This is what? Extreme down condition. So these are the extreme conditions too. This is the mean position. Okay. If the motion start from E, motion starts from E. In that case, what is theta? It is 0 or 360. 0 or 360 degrees. Okay, in terms of radian, we can write as 2 pi. 2 pi, 0 or 2 pi radian. Okay, after that, suppose the motion is not started from point E, it will start at point F. What will occur? At point F, it will start. Then how can we find out the angle theta? As we have started the motion at this point, if we goes here, it becomes 360. plus this 90. So this would be, now this would be the mean position. Why this is mean position? Because motion starts here. So this F and H are said to be mean position. G and E are said to be extreme position. And in this situation, what is the value of theta? Here, from this place, we goes here. It is 360. Okay. Plus this 90. So it become 360 per 9 plus 90. Just look at a special case. The first they have taken theta as 0. As because we have started the motion from point E. So theta is 0. When we started the motion from point F, theta equal to what? It is can be written as 360 plus 90. It is said to be 360 plus 90. So we can write the cases. The first, theta equal to 0. Second, theta equal to 360 plus 90 degrees. All these I have written only in degrees. Let's go to third. If the motion started from point G, again this would be the mean position. These are said to be extreme position. Then what is theta? If motion started from G, it is here 360 plus this. Started here 360 plus 180. So we can write theta equal to 360 plus 180 degrees. Apart from this, if the motion started from H, it is what? 360 plus 270. So it is said to be theta equal to 360 degrees plus 270 degrees. So this we have seen in degrees. Same thing you can write in, that is radian, we can say. Same thing in your book they have done. So it is 0, it doesn't matter. 360 means what? We can write this as 2 pi plus pi by 2. Here it is what? 2 pi plus here pi. Here it is what? 2 pi plus 3 pi by 2. So these are nothing but what? The same angle in radian. Same thing they try to explain here. So here 2 pi is common here. 2 pi 0, or we can write it as 2 pi. So 2 pi is common everywhere, here, here also. So this 2 pi represent what? This omega t it will represent. After pi means this, pi by 2 pi, 3 pi by 2. So these are nothing but a initial phase. Now remember, while doing this, below this they have taken an example 5.7 and 5.8. They are very interesting example. Try to solve it. Try to solve, instead of that, try to understand that example. Once you understand that example, then you get a concept of this point. What exactly phase of SHM. Now see, when we say the angle is here, that I hope you can do that 2 examples. So we can go to next topic. You just try to understand only that. If you didn't understand, then I will tell you. Okay. So try to understand these 2 examples first. If you got it, it is well and good. And I think it's very simple to just know that thing. So I hope you can find it out. In one example, 5.7, they have given the angle and we have to find out the amplitude. They have given the angle and we have to find out the amplitude. Second case, they have given the amplitude, the displacement we can say, and we have to find out the angle. Both the cases are simple. Just try to solve it. Very, very easy. And remember, these 2 examples are very, very conceptual and very important to understand this topic. Okay. So try to find it out. Try to understand it. Now let's go to next one. Graphical representation of SHM. What exactly graphical representation of SHM means? Simple harmonic motion can be of 2 types, as we have learned. Either motion start from one point, that is said to be mean position, or motion start from extreme position, and that can be represented in terms of graph. So that is said to be graphical representation of SHM, simple harmonic motion. As there are 2 types of motion, either motion start from mean or extreme position. So there we get 2 plots. Out of this, I will tell you the one, single one, motion start from the mean position. Similarly, you try to understand if the motion start from extreme position, what are the graphs. Okay, it's very simple. Once you get the first, second you can find it out. And I am going to give homework that one to you. Okay, so before going detail, let's start with the first. So the first part is motion start from mean position. Mean position. If the motion start from mean position, how it will be represented by graph. that is said to be graphical representation of particle performing simple harmonic motion. It start from a mean position. It start means what? We have started counting the time from the mean position. In this situation, as we know, we have the equation for displacement x equal to a. Just I will write down this little bit here, or little bit I will write down this one side. I will write it to this side first. So we can write this as x equal to a sine of omega t plus phi. But when motion starts from mean position, it is seen that phi is 0. So you can write this as x equal to a sine omega t, because at mean position, if you put an initial condition at mean position, x is 0 and we have started a time t equal to 0. Put that here, you get phi equal to 0. So we can write this as x equal to a sine omega t would be the formula. Once we know the displacement, you can find out the velocity. So velocity equal to rate of change of displacement dx by dt, and acceleration is equal to rate of change of velocity with respect to time. So in this situation, it is very simple to understand. Just find its derivative, you get velocity. Find the derivative of velocity, you get acceleration. So find out the velocities, that is derivative of this. A is constant, it is said to be amplitude. What is derivative of sine omega t? It is cos omega t into derivative of omega t is omega. So we can write, I hope you know this, so we'll write directly because already we have learned this. A into omega cos of omega t. Sine's derivative is cos, omega t is omega. So that I have taken initially, a omega cos omega t. Similarly, you can write the acceleration. Derivative of cos is what? Minus sine omega t. So we can write minus a omega sine of omega t into derivative of omega t is omega. That omega, this omega becomes omega square. So such type of formulas we have derived. This is for displacement, velocity and acceleration. I hope you got this topic. Now let's go. From this, what we have to do, we have to draw one table as they have given in your book. On page number 118, they have given the table. That table we have to prepare. So remember, there is one simple trick to solve that table. Or just it is not essential to remember it. You can just use a simple trick or just simple formula to understand. Just remember the first row first. So let's see what they have done. That's why I have just write this to this side, so we can draw the table here. So first is a t. They have written the t means the time. So this is time first. Then they have find out omega t. Okay. Then they have find out displacement, then velocity, then acceleration. Such type of simple table they have find it out. So I will write accordingly. Just draw the table. Just for sake of understanding, I have just draw the table. Let's start with the time. Time can be changed as just 0 t by 4. So it is 0 first. Then it may be t by 4. Then it may be t by 2. Then it may be 3t by 2. 3t by 4. Not 2, it must be 3t by 4. Then it will be t. Then it would be 5t by 4. The next one, 5t by 4. So such type of things they try to explain here, and this would be the table. Now here the value of t they have mentioned, we have to find out omega t. Just look, in your book they have written the theta, I have written omega t. It's both are simple. Theta is angular velocity equal to what? Sorry, angular displacement is equal to, just we can write omega equal to angular displacement divided by t. Omega is angular velocity equal to angular displacement by t. This implies that theta equal to omega t. So this theta equal to omega t. I have just taken omega t. In your book they have written a theta. Both are same. Theta equal to omega t by this formula. Okay. Now just I will rub this formula. Now let's go further. Here, once we know the value of t, you can find out the value of omega t. How can we find out omega t for first? As t is 0. Just put it here. 0 into omega is, definitely it is 0 here. Okay. Let's go to next part. T equal to t by 4. Put it here. So we can write this as omega t. Theta equal to omega t, where t is t by 4. Put it here. You can write this as omega into t by 4. What is omega is? 2 pi by t. So you can write it here as omega is equal to 2 pi by t, put this value here, solve the equation. So I can write here like this: 2 pi divided by t into t by 4. This t cancel with this t. Okay, this 2 cancel with this 4, it becomes 2. So what is remaining? It becomes pi by 2. It becomes pi by 2. So this would be the pi by 2. By same method, put here t equal to t by 2, 3t by 4, t, 5t by 4, and just put the value of omega 2 pi by t. You can find out a table. Just I will write down directly now. So it is pi, 3 pi by 2. Okay, then it is 2 pi, then it is 5 pi by 2. I hope you know this part now. Once you know this formula, you can find it like this. Now apart from this, just write down the equation for displacement now. Just put the value of that things, theta or omega t, in this equation of x. What we get? We get displacements. If you put the same values in the equation of velocities, you will get the velocities. In case of acceleration, we get acceleration. So first of all, put in case of displacement, x equal to, here x equal to a sine of omega t. When sine of omega t is 0, what would we get? Suppose omega t is 0. So what we get? This 0 we have to put here. Sine 0 is 0. So x equal to 0. Okay. Sine 0 is 0. X equal to 0. Sine of pi by 2 means sine of 90. It is what? 1. So sine of 90 is 1. This is 1. What is a? It remains a. So it is plus a, we can say. Plus a. Amplitude. Okay. Then sine of pi, 0. Once you get this, start repeating, alternate with sign is different. It is plus a, 0, minus a, 0, plus a. That's it. So on. So on for further also. So just remember that we have just find out by putting the value of omega t, is that is theta equal to omega t in the displacement. Similarly, put the value of this omega t in the equation of velocity here, cos omega t. So cos omega t, a omega cos omega t. Cos 0 is what? Omega t is 0. Cos 0 is 1. So it is a omega. So here it is a omega. It is plus. Okay. Cos of 90 is what? 0 into anything, it is 0. Cos of pi is what? Minus 1. So minus a omega. Repeat it now. 0 plus a omega. 0 minus a omega. So on. Similarly, for acceleration, put omega t is 0 here. Sine 0 is 1. Sorry. Sine 0 is 0. Sine 0 is 0. So 0 into anything, it would be 0. Sine of 90, put omega t as pi by 2 here. Sine of pi by 2 means sine of 90 is 1. Minus a omega square. That is only the difference. Minus a omega square. Then it is 0. And repeat it. Plus a omega square. 0. Then minus a omega square. This would be the table. And you can just see this table with a table as they have given in your book. Both the tables are same. Once you are able to plot these tables, you can plot the graphs. Okay. But remember, when you plot the graph, suppose the question come in a board examination, represent a simple harmonic motion in a graphical form such that the motion start from mean position. And it has suppose 2 mark question. Might be you got a little bit idea in your mind that you get a half mark for these equations. You may get a half mark for this equation. This table, this equation half, this table half, and remaining 1 mark for the plot. No, you are totally wrong. In that situation, the marks are given for a plot because graphical representation was asked. So you must write graphical representation. But to write the graphical representation, it is essential to write the equation. From this equation, you get a table. From this table, you can plot a graph. That's why all things are important for our point of view. But exam point of view, examiner or just paper checking examiner is interested to see the plots only. He will give the 0 mark for this. It will accurate but 0. This is accurate but it is 0. because the question is for graphical representation. Is that clear? And that's why, so you have to plot a graph properly. So I will plot the graph here. I will try to plot the same graph for a particle performing SHM starting from a mean position. We will plot that graph here on this side. Let's start with here. So I will write this line first. General line I have drawn. General line we have to draw, that is y-axis we say. Let us say start with this. So suppose this is the y-axis. Okay. Just we want to plot the three graphs: displacement, velocity, acceleration. So just make its three parts. Suppose this is the first one for this first one for displacement, second one for velocity, and third one for acceleration. Now just take a x-axis from the center like this. X-axis here. This is the x-axis. This is the x-axis. Okay. Now we have to plot the graph. Now in case of, just look at the table. In case of this displacement, its value is plus a or minus a. Again plus a, minus a. Zero is there, but basically it is plus a, minus a. So just do one thing. Here write down it is plus a amplitude. It is write down here minus a as an amplitude. Similarly for velocity, plus a omega, minus a omega. So here it would be, suppose I will write it here somewhere, plus a omega. Here it is minus a omega. In case of acceleration, what is that? In case of acceleration, what is that? Just look at the table. It is a omega square. So it is plus a omega square here, and here it is minus a omega square. I hope you know these things. Now let's start the displacement. Just see the table first. When time is 0, let's take this axis is nothing but what? Time axis basically. This is a time axis basically. This is a time axis basically. Time, or we can say it is omega t. Time, sometime you can take a time also. Some book they have used omega t. Some book they have used a theta also. When we take it as theta, you should write it in radian. Radian, values in radian you have to write. So theta means you have to write this as 0, pi by 2 pi, 3 pi by 2, 2 pi, 5 pi. But in your book they have taken time only. So write down according to the book, it is time. So write down, before going into detail, so just make some 4 to 5 vertical lines. 5 vertical lines equidistance you have to draw. So I will write this as a first one, suppose. I will write down this second one, suppose. I will write down this is third one, suppose. It must be exactly vertical. Suppose it is fourth one, and equidistance. And this is fifth one. I have drawn these 5 lines. Okay. Just sake of understanding, it's good to draw. Now let's start with here. When here, just look at the board. When time is 0, x is 0. So here it is x. Time is 0 here, x is 0. Point we get here. Okay. Next one. Time is t by 4. X is plus a. Let's take this as a t by 4. T by 4. Then we can take it as a, this one as t by 2. This one as 3t by 4. This one as t. This one as 5t by 4. Because we are drawing the graph time versus displacement, time versus velocity, and time versus acceleration. You should represent this as x because it is displacement. You must represent this as a v because it is velocity. You must represent this as a because it is acceleration. If you don't mention this as a, v and x, might be 0 mark will be given by examiner to you. So take a precautions. Now see, this is the first point, t equal to 0, x equal to 0. T equal to t by 4, x equal to plus a. T by 4, it is a plus a, points come here. Just connect it like this. Okay. Then x equal to t by 2, t equal to t by 2. What is x equal to? 0. T by 2, it is 0. It comes here. So we can draw it like this. Similarly, next 3t by 4, it is minus a. Point comes here. So you can connect it like this. So this would be the point. Then for t, it is again 0. So connect it like this. Again 5t by 4, it is a plus a. So just this is the point, connect it like this. So this would be the graph for displacement as we have plotted, and for further it will go down, up and so on. Down negative, again 0, again positive. That is a displacement curve. Displacement, graphical representation of displacement for a particle performing simple harmonic motion. Similarly, you can draw the velocity. Just look at t equal to 0, velocity is plus a omega. So t equal to 0 here, velocity is plus a omega. This is the first point. Then t equal to t by 4, velocity is 0. So t equal to t by 4 is this, velocity is 0. So this would be the point. It comes like this. This comes to be like this. Then for next t by 2, it becomes minus a omega. This would be the point. So connect it like this. Just connect it to the negative direction like this. After that, it becomes for 3t by 4, it becomes 0. The point comes here. It goes to this point. Okay, I will write this again. So this is the point. This goes here for 3t by 4. For time period t, it becomes plus a omega. This would be the point. So it goes up like this. And for t equal to 5t by 4, this point, it comes to be the 0 level. It again comes to the 0. So this would be the graph. This would be the graph for velocity. Similarly, you can plot a graph for acceleration. As t equal to 0, acceleration is 0. So t is 0 here, acceleration is 0. So this is the first point. As t equal to t by 4, acceleration is minus a omega square. Minus means goes downward. So it is minus a omega square. Did you got it? No, you can't see that. Let's see here. I will put the mobile down. Then you can see the same thing. Just adjustment is there. So we have to adjust I have to adjust the camera actually. So minus a omega square. Here is the point. Do you got it? Yes. Now this point goes downward direction. Now for t equal to t by 2, it becomes 0. It goes to 0. Again for t equal to 3t by 4, it is plus a omega square. It goes to this point. Again for t, it goes to 0. This would be the point. Again for this, it goes to higher point. In this fashion, this graph repeated again for this acceleration. Now remember, this is a graphical representation of, this is said to be graphical representation of displacement, graphical representation of velocity, graphical representation of acceleration. Now see, this is a sine wave. Definitely it starts from 0. So it is said to be sine wave. Again, this velocity start from maximum. It is said to be cosine wave. Acceleration start from 0, goes downward, doesn't matter. So this is sine wave. So point to remember is that in case of this, the displacement gives the sine curve. So this displacement is a sine curve. Velocity is cosine curve. Acceleration is again sine curve. So in your book, they have just drawn some conclusion from this. What are the conclusions from the graph they have drawn? Let's look at here. So this should be the sine, cosine, sine. Second conclusion, this displacement and velocities are, there is a phase difference of pi by 2 or 90 degrees. Pi by 2 radian or 90 degrees between displacement and velocity. Similarly, phase difference of pi by 2 radian or 90 degrees between velocity and acceleration. Okay, pi by 2. And there is a phase difference of pi radian or 180 degrees between displacement and 180 degrees means what? It goes up, it goes down. Exactly opposite. So there is a phase difference of 180 degrees. Okay, and in all this, just look at the book. Accordingly, book we go. Displacement, velocity, and acceleration are simple harmonic, are periodic function of time. Yes, definitely, because these waves are repeated itself. See, start here, complete it here, again start at the same point. Again, the structure is same for next. So it is periodic, repeated again and again with the same structure, changing with time. So it is a periodic waves. So periodic waves. So that is the first thing. Displacement also, this velocity also, acceleration also. It start here, goes here, again repeated again here. So that is nothing but these are the periodic curves, or we can say periodic curve means periodic functions, means the motion is periodic. And we know simple harmonic motion is a periodic motion. Let's go next. Displacement time curve, acceleration time curves are sine curve. And already told you, this is sine, this is sine, because they start from origin. And the velocity time curve is cosine curve, because it is cosine function. So let's go third. There is a phase difference of pi by 2 radian between displacement and velocity, pi by 2 radian between velocity and acceleration, and pi radian between velocity, displacement and acceleration. That already I have told you. Next one, there is a phase difference of pi by 2 radian between velocity and acceleration. That already I have told you. There is a phase difference. Shape of all curves get repeated after 2 pi radian or time t. Just I have told you initially, same. After this time t, here, this curve get finished. Again, next curve get repeat like this. Again at this point t, here it will be t. Again the curve repeated again here as a cosine. Again a time t, it becomes sine. So that is the motion repeated itself in equal interval of time again and again. Same type of motion. So that is periodic motion. That's it. So in this fashion we have learned this. Now remember, this is the variation of time with a displacement, time with a velocity, time with a acceleration. But might be in your book little bit they will ask the question as a variation of the displacement, velocity and acceleration with respect to theta angle. In that case, what should be the change? I will write down here. See, this t by 4, t by 2, it is applicable to this graph also, this graph also. It is better to write everywhere. You must write this t by 4 here, t by 2 here. So this is t by 2, here 3t by 2, here it is t, here it is so on. Everywhere we have to write. But I have not written because I would like to give the next solution. If the question asked is that represent the graphical representation of particle performing simple harmonic motion with respect to angle or omega t, what are the changes? So instead of this t, it becomes theta now. Theta equal to omega t, because that was asked. So we get omega t here. Instead of this time, you should write 0 pi by 2 pi. Here it would be 0. It is pi by 2. Here it is pi. Here it is 3 pi by 2. Here it is pi. Here it is 5 pi by 2. So this is the graphical representation, same. But this is in terms of pi, means with respect to angle or omega t. In terms of t, means with respect to time. The change is what? Here it should be t. Here it should be theta equal to omega t. Here it should be t by 4 and so on. Here it is pi by 2 pi and so on. Okay, graphs remain same. There is no change in the graph. So this is nothing but a graphical representation of particle performing simple harmonic motion starting from mean position. Similarly, you can draw, you can write down first equation. Second part, this is the first one. Second part, particles start from extreme position. So what is the modification in extreme position? That I would like to tell you. What is the modification here? So look at here, modification is what? In that case, what is remaining, or what is the change that I would like to tell you? I am not going to teach you that topic. It is exactly same. So you have to just prepare yourself. Okay, that would be the homework. Just I will tell you the basic idea. So this is the second part. So the particle performing SHM starting from extreme position. Now the graph becomes same. So these values are same. Only the values of displacement get changed and the velocity get changed and acceleration get changed. These values get changed only. That's it. Nothing get changed. Equations get changed. That's why this value get changed. And accordingly, the columns of table remain same. Only this value little bit get differ, and that's why I am going to erase it. Now, what is the remaining? These things that you have to plot this graph. Okay, and I know that you can plot this graph well. And remember, for this graph, this for displacement it is half mark. For this it is half mark, and for this it is half mark. And half mark is for nomenclature. Plus a minus a, that names we have written, t by 4, that thing we have written. For that, the half mark. So total marks would be 2 for this. If the same question was asked for 3 marks, then definitely the marks would be given for displacement graph 1 mark, for velocity graph 1 mark, and for next one, that is acceleration graph, it is 1. This table doesn't have a marks. But remember, apart from this, I have drawn this as sine wave, cosine wave. Lot of students, what they will do when such type of question get asked, they will draw, everything would be right, but they will draw the wave like this. they will draw the wave. It is better to write like this. They will draw the wave like this. Such type of wave they will write. Remember, this is for displacement, velocity and acceleration. They will use a scale and quickly they can draw like this. But remember, these things are wrong. If you do this, everything is right, exactly same. Everything is nomenclature same, plus A, minus A, everything is same. Still you get 0 marks. Why? Because this is not a sine wave or cosine wave. This is triangular wave. That is different meaning. That's why it would be 0. So this wave must be sine wave like this. It must be smooth one. Then and only then you get the marks. Otherwise the marks get cut out. Let's go. For your equation you should write x equal to a sine omega t plus phi that we have written. And finally, if the motion starts from extreme position, displacement would be represented by x equal to a cos of omega t. A cos of omega t. How this equation we get? Put omega t plus phi. That we know the general equation. X equal to a sine of omega t plus phi. Put the condition here, t equal to 0, x equal to plus minus a, because motion starts from extreme point. So it is either plus a or minus a. If we put it, the value of phi comes to be pi by 2. Sin pi by 2 minus theta, it comes to be what? Cos theta. That is nothing but a cos of omega t. So that is the part. So this displacement for motion start from extreme position. Find out the velocity, rate of change of displacement with respect to time. Find out the acceleration, rate of change of velocity with respect to time. So what is derivative of cos omega t? It is minus sin omega t into omega. So it would be a omega sine of omega t with a minus sign. What is the derivative of a omega sine omega t? It is a cos omega t with a minus sign. Minus a omega square, sine becomes cos omega t. So these are the three formulas, and from these three formulas just put the value of omega t as 0 and find out the displacement here. Similarly, find out omega t is 0, t by 4 and so on. Find out the velocity and acceleration. Then you can draw the same graph as we have learned, but the structure get reversed. Exactly opposite graph you get in case of motion start from extreme position. When you have in the initial case, when you start from mean position, displacement and acceleration are sine curves. Okay, velocity is cosine curve when the motion start from mean position. Exactly opposite get occurred when motion start from extreme position. The sine curve is nothing but a velocity represent the sine curve. Displacement and acceleration gives the cosine curve. Conclusion remains same. Is that clear? Because out of phase, pi by 2 radian, phase difference, they are symmetrical. They will show the periodic waves. That remains same. Now let's get to next topic. That is nothing but a composition of SHM. Now let's go to the next topic of your syllabus. Composition of 2 SHM. What is meant by composition of 2 SHM? Means what? We have taken two particles separately. They are performing simple harmonic motion separately. Okay, with a different time period, or we can say different phase and different amplitude. They are performing the simple harmonic motion with a different amplitude and different phase. Two particles. Suppose this first particle P1, this second particle P2. Both of them are performing simple harmonic motion. Only here it is performing with amplitude A1, it is performing with amplitude A2. Apart from this, here the phase difference or the phi becomes different. Phi 1, it is phi 2. Now such type of two motions having the same time period, time is same, t is same, time period is same, only there is difference in amplitude and phase. Phase and amplitudes are different, time period is same. So as phase and amplitudes are different, they have different displacements. It has a displacement x1, it has a displacement x2. Such type of two particles performing simple harmonic motion with the same time period, the same periodic motions, but they have different amplitude and phase. When we combine these two motions together, whatever resultant thing get created, resultant motion get created, whether that is simple harmonic or not, that we have to consider under this topic. So to understand this very well, that is said to be composition of 2 SHM. To understand this very well, I will tell you one of the best example for this as according to your book. Suppose we have this rigid support, or we can say instead of rigid support, we just tied one string to the two walls. So this is the first wall part, this is the first wall, this is the second wall to this opposite side. I have tied one string here, or thread we have tied between these two walls. Tightly just we have bind the string or thread. And to this I have taken the first pendulum, simple pendulum. Suppose this is the first simple pendulum I have taken, or first particle we say P1. Okay. Similarly, this is suppose second particle here, it is suppose P2. Both are performing simple harmonic motion. Only difference is what? Its amplitude is this much. This much is amplitude minus A. It goes somewhere here with the same amplitude plus A. It goes here like this. But this has more amplitude like this. It goes here. It has different amplitude. A1 suppose, here it is A2 plus A2 minus A2. Amplitudes are different. Apart from, I have connected a third pendulum here, which might have different length. Here, third simple pendulum, and that is P3. And P3 is nothing but what? Combination of P1 and P2. When I have moved this P1, just move it here, leave it. It will perform to and fro type of motion. It will start performing simple pendulum. Both of them are performing simple harmonic motion. But due to this, automatically after some time, this particle 3 or this simple pendulum P3 start performing simple harmonic motion by combination of these two, and that is said to be resultant motion. By combining these two motion together, how they together work, that was represented by P3, and that we have to say to be composition of two particle performing simple harmonic motion of different amplitude, different phase phi, it is phi 1, phi 2, but same time how they behave after combining, that was represented by this pendulum P3. Same thing we have to learn under this topic. So let's start with these two motions and represent them by the two different equations. Let us suppose the first displacement is represented by first particle motion represented by x1, second represented by x2. So we can write here x1 equal to a1 sine of omega t plus phi 1, x2 equal to a2 sine of omega t plus phi 2. What is the difference here? Amplitudes are different, time is same, phase difference are different. That's why the displacements are different. So when such type of two particle performing simple harmonic motion combine together, the resultant motion, what is the nature of resultant motion? Is it simple harmonic or not? That we have to learn under this topic. For that, resultant displacement, suppose this is displacement produced by first particle, displacement produced by second particle. If we remember, we have seen the principle of superposition of wave. At that time we have learned resultant displacement is sum of the displacement of each particle produced separately. That formula we will use. So resultant displacement x equal to x1 plus x2. Just put that formula, write down, then put the values. X equal to this a1 sine of omega t plus phi 1 plus a2 sine of omega t plus phi 2. I have just put this value of x1 here and x2 here and rewrite the equation. Now might be all of you learn about the equation for trigonometric equation sin a plus b, sin a cos b plus cos a sin b. That formula we have to use, sin a plus b, sin a plus b. Write down for this. So you can write this as a1 sin a plus b is what? Sin of omega t into cos of phi 1, sin a cos b plus cos a sin b plus this a1 is multiplied, so you must take here plus a1 also. Okay, write down the same formula for this. So plus a2 sin a plus b sine of omega t plus cos of phi 2 plus a2 cos of omega t into sine of phi 2. So just we have applied the trigonometric formula for sine a plus b. Those who don't have mathematics, don't worry. These are the basic formulas we have learned in 10th standard, 9 to 10 standard, sine a plus b. So we get this type of equation. Now we can write the same thing. Just take some common term and rewrite the equations. So in this case, here it is sine omega t, here it is multiplication. Sine omega t, here it is sine omega t. Take it common. We can write here equal to sine omega t, we have to take common, a1 cos phi 1 plus a2 cos phi 2. Remaining term is what? Sine of omega t, that we have taken common, plus these two terms, remaining two terms. Take this cos omega t common here and rewrite the equation. So you can write plus a1 sine of phi 1 plus a2 sine of phi 2. Outside it becomes cos of omega t. So this is the displacement x equal to. Now in this equation, what you have to do, you have to put some values. What the value we have to put here? So these things, we have to put one constant value, or we have to just use some that the basic formulas, or just put some substitutions. What are the substitutions? This bracket, put it as r cos delta. Put this as r cos delta and put this bracket as r sin delta, r sin of delta, and rewrite the equation. What we get in the equation again? We get here x equal to, this is r cos delta, r cos of delta, this one into sine of omega t plus r sine of delta into cos of omega t. Again use the formula in opposite direction, sine a plus b. Just take this as a, this as a b. Use the formula. You can write x equal to, r is common, sine of omega t plus delta. Now compare this equation, x equal to r sine omega t, with the basic equation of the 2 Shm that we have written here. Just compare x equal to r sine omega t with this. x1 equal to a1 sine omega t plus phi 1, a2 sine omega t plus phi 2. Here phi 1, phi 2 are here. Here just omega t plus delta would be there. So this equation and this equation for x1 and x2 are same. And that's why we can say the resultant motion produced by combination of two particle Shm is again the simple harmonic motion. Okay, is again the simple harmonic motion. Just put this equation. We have put this equal to this now. Suppose this equation 1. Put this equal to this equation 2. Just I will make the adjustment. Equation 1 and 2. Now what we have to do? We have to find out resultant amplitude here. How can you find out the amplitude? Resultant amplitude that we want to find out. Now for that, just if you have the book, this equation we have put here as equation 1 and 2, equation 5.17 and 5.18 from your book, same equations. Now we are interested to find out the amplitude and the phase. Means we are interested to find out r here, this r we want to find out, and we want to find out delta. For this, square the equation 1 and 2 and add them. Square the equation 1 and 2 and add them. Left hand side, r square sine square delta plus r square cos square delta. R square is taken common. Sine square plus cos square delta is 1. So you can write this as r square equal to, I will write directly, r square cos square theta delta plus r square sine square delta. R square taken common, sine square delta plus cos square delta is 1. So that I have written as r square only. R square into 1, it is r square. Let's go to right hand side. This square plus this square, I will write that. So this term a1 cos phi, this is bracket. Whole bracket square is what? A square plus b square plus twice ab. Similarly, This would be a square plus b square plus twice ab. That we have to write. So write down here, right hand side. Write down here the right hand side of the equation by squaring that. A1 square cos square phi 1 plus a2 square cos square phi 2. Okay, plus twice a1 a2 cos of phi 1 into cos of phi 2. This is the first part we got. That is the first part we get. Plus square of equation 1 it is. Just square the equation 2. Just you can write a1 square sin square phi 1 plus a2 square sin square phi 2 plus twice a1 a2 sin of phi 1 into sin of phi 2. So we get this equation. In this case, let's take common things. Sin square phi 1 plus cos square phi 1 is 1. A1 square is common. So you can write this as a1 square because sin square theta, sin square phi 1 plus cos square phi 1 is 1. Similarly, this sin square phi 2 plus cos square phi 2 is 1. So what we get? A1 square plus A2 square. Plus remaining term is this. Twice A1 A2 if we take common. This twice A1 A2 if we take common. It is sin of phi 1 into sin of phi 2 plus cos of phi 1 into cos of phi 2. That is cos A minus B. In our case, A is phi 1, B is phi 2. So we can write plus twice A1 A2 common. This will result into cos of phi 1 minus phi 2. Cos of phi 1 minus phi 2. That we get a R square. This we get a R square. This implies that R equal to square root of this a1 square plus a2 square plus twice a1 a2 cos of phi 1 minus phi 2. That is nothing but R. That is nothing but R. R is nothing but what? Amplitude we have find out. Amplitude of resultant composition that we have find out R. Similarly, if we divide equation 1, just we have square and add, we get this R. Okay, divide equation 2 by 1. So R sin delta divided by R cos delta. Thus R get cancelled out. Sin delta divided by cos delta is what? So this is one of the equation we are interested. Then next is what? Tan of delta equal to. Okay, 2 by 1. So you have to write A1 sin phi 1 plus A2 sin phi 2 divide by A1 cos phi 1 plus A2 cos phi 2. We get tan of delta. What does tan delta means? Delta equal to divide both sides by tan. Tan inverse of same bracket. This same bracket. Just take its tan inverse. That we get delta. Delta is what? Phase we get. Phase. R is what? Amplitude we get. Once again we will derive the same equation. In short, what we have done, first of all we have considered two motion represented by x1, x2. x1 equal to a1 sin omega t plus phi 1, x2 equal to a2 sin omega t plus phi 2. Then resultant displacement is x1 plus x2. Add these two, put the values. So this plus this we have written. Use the formula for sin a plus b. So just we have used it here. Use the formula for sin a plus b. We have put it here. Just take between these two sin omega t common. Here cos omega t common. Remaining things are in the bracket. Just take this cos phi 1 plus cos phi 2 bracket as r cos delta. Sin bracket as a r sin delta. And just equation 1 and 2. Just we can write this as r taken common. Cos delta plus sin omega t plus sin delta plus cos omega t is r cos omega t plus delta. If we compare this equation with the original equation, here it is phi 1 phi 2, here it is delta. Here it is a1 a2 amplitude, here it is r. So this is a resultant motion with a amplitude r, phase difference delta. Now we want to find out the amplitude and phase of resultant motion. For that, what we have done, we have squared this equation 1 and 2, means these terms, and add them. We get to this. So we get this equation. Just solve it further. If we solve it further, cos square sin square phi 1 plus cos square phi 1 is 1. So it is a1 square common. Similarly a2 square common plus twice a1 a2, and these two terms added together is cos phi 1 minus phi 2. This is r square. So what is r? Square root of this term. Okay, in this fashion we have find out the amplitude r. Similarly you can find out this delta. For that, divide equation 2 by equation 1. R sin delta by r cos delta. R get cancelled out. Sin divided by cos is tan. So we get here this tan delta equal to this thing. Right hand sides are like this. So delta equal to tan inverse of this same bracket. That will give the value of delta phase difference. I hope you know. I hope you got how we have derived the equations. Now let's go further. Small special cases are required. Just special cases we have to solve. Within 5 minutes we solve that cases and we will stop here. So let's start with the special cases. What are the special cases here? There are 2 to 3 special cases they try to solve. So we will try to solve the 3 cases. And just we are interested here now only for this amplitude. We are interested in amplitude. So and delta also suppose. So we can write this. From this amplitude we have to write the special cases. So the first special case. So these are the special cases. What are the special cases or special conditions? For first special case, when the two particles P1 and P2 performing simple harmonic motion, they are in same phase. They are start here. Suppose they are start at the same time here. They goes here same time. So we can say, so this is P1, P2 goes here, comes mean, goes extreme at the same time. So they are said to be in phase. If they are in phase, phi 1 minus phi 2 is 0. In that case, that is the first case. If phi 1 minus phi 2 is 0, means the two waves or two motions are in same phase. In that case, if this is 0, what is the cause of 0? Just in case of this formula of resultant amplitude r, cos of phi 1 minus phi 2. If this phi 1 minus phi 2 is 0, cos 0 is 1. So what we can write? R equal to square root of a1 square plus a2 square plus twice a1 a2, and you can write this as square root of a1 plus a2 whole square. Outside the square it is a1 plus a2. Okay, just addition of their amplitude is a resultant amplitude of motion. Now in this situation, suppose both the wave has same amplitude a1 equal to a2 equal to a. What is r? What is r in our case? Put it here, a plus a twice a is a resultant amplitude for this such type of motion. That is the first case, first special case. Let's go for second special case. I will write down the second special case somewhere here. Let's take the second special case. Second special case says that if the two waves are such that there is a phase difference of 90 degrees between the two particles P1 and P2. First goes here. Suppose first goes here. Here it is mean. Second is here. It will start here. It will start here. So that is a phase difference of 90 degrees. In that case, phi 1 minus phi 2. Phi 1 minus phi 2 is 90 degrees. That is pi by 2 radian. Then what is cos of phi 1 minus phi 2? Cos of 90 is 0. So if you put that value in the equation of this r, here this 0 into anything is 0. What is r then? R equal to square root of a1 square plus a2 square. Square root of a1 square plus a2 square. Now again here, if a1 equal to a2 equal to a, what is this? Square root of twice a square equal to square root of 2 outside the square root, it is a. That is the resultant amplitude for this condition if the two particles perform simple harmonic motion with a phase difference of pi by 2. And the last and the third case they have mentioned, if the two particles are performing SHM such that they are out of phase. First goes here, second goes here. When it goes like this, they are said to be exactly moving opposite. They are said to be out of phase, or phase difference is 180 degrees. In that situation, the third special case goes phi1 minus phi2 is 180, means it is pi. What is the value of cos pi? So that is, we want to find out cos of phi1 minus phi2 now. Phi1 minus phi2 means cos of pi is minus 1. So just put the value in r, we get r equal to square root of a1 square plus a2 square minus twice a1 a2. And this is nothing but what? This is nothing but what? Square root of a1 minus a2 whole square, that is equal to a1 minus a2. Again if a1 equal to a2 equal to a, here if we put this both are a, this r comes to be 0. So when the two particle performing simple harmonic motion, exactly opposite direction, out of phase, or phase difference is 180, resultant amplitude is 0. Otherwise, if they are in phase, resultant amplitude becomes double. If they are in phase, it becomes double, same amplitude if they have. Otherwise, in this case 90 degrees, root 2a. Opposite direction, that is out of phase, 180 degrees, it is 0. So these are the special cases. After that, they have given one activity in your book, and that activity already I have told you when we start this chapter. Oh, sorry, when we start this topic. First pendulum P1, second pendulum P2, both are performing Shm. Then we have considered third pendulum, which is the combination of these two, that is the third pendulum. What type of motion it has, and that is we have studied composition of particle performing simple harmonic motion with a different amplitude and different phase. Resultant motion is again simple harmonic. Then we have seen the three special cases. Take care, then we will see next topic. So the next period we will start the next topic, energy of particle performing Shm. Definitely read this. First of all, just see this video, then read the same topic from your book, and don't forget to give the like and subscribe my channel. Thank you.